Good day and welcome to this very quick Power BI starter walkthrough. Our goal today is to go through very quickly some Power BI desktop fundamentals applied to transportation analytics in this case. So looking at some data connections and some strategies that are come out of the box with Power BI for importing operational data. We're going to look at Power Query for rail data transformation. We're building some basic performance monitoring data models. Data model meaning, we're capturing data from operations within the organization, and we want to be able to create a model of the organization's architecture on the basis of the data that we capture from it. We'll go into that in future sessions. Perhaps maybe go through some very basic DAX calculations to generate some metrics. So we are going to be working with some data, of course, and we're going to be creating what is called a star schema that represents basically the operations data set. In this case, we've got some facts tables. We've got two facts tables. We've got the stop calls, which includes facts about our operations. So the date of the service, the service ID, the operating company, the station code, planned arrival, actual arrival, and that sort of data, facts about the operation. Or they could do measurements, they could do just information about our operations. We also have delay attribution. Another sort of facts table that we have, what is causing delays, right, as we aim to deliver the service of rail transportation. Okay, we've also got these dimension tables. We've got the operating components. Okay, as a dimension table. We've just got just a few of them right here. Just for instance, some total data set. This is synthetic data that we have generated to mimic railway operational data set. So we've got this, the stations as a dimension as well, and the key difference between the facts table being measures and actual collected information about your operations. But the difference between that and a dimension table is that the dimension table provides context to the facts of the operation, and we'll talk about that a bit more as we go through the demonstration. And we've got dates, of course, because train travel happens over time. So we will have to be analyzing that service, aspects of the service all the time. So that's that about our data sets in a nutshell. So if you go into your Power BI desktop, again, when you fire that up, when you open up Power BI, it'll probably come up with this window here where you can select a blank report, and then if you select the blank report, it will pretty much bring you into this window that we have here. And once we're in here, the key thing to know is it brings you to what is called the report view. You can see these sort of perforations that goes around the edges over there. So that is the extent of the real estate that you have available to you for creating reports using some of these visualization. We'll come to that once we've brought to some data. And you can sort of navigate with this left panel here. So we have the report view, just hovering over that there. Of course, we have the table view, which is associated with your data view, and that data view persists in some sense. And up here, because we're in the report view, we have visualizations, but as you can see, we can open that up, expand that, and we have our data view here to do that. And we'll see that well integrated the data. Of course, here in this left navigation panel, we have the model view. And model view is where we manage basically relationships between the tables or our data sets. So this is where we'll build our star schema representation, and we can manage performance relationships within this window. Okay, so these three windows are things you're going to be working with a lot: the model view, the table view, and the data will look just like a normal Excel sheet out, and the report view where you create loads of reports. Okay, so we are going to bring some data in here, and we would do that just at this top the ribbon here, will just navigate, and this is the home aspect. I'll just talk a little bit about this ribbon here. So we've got the home tab, we've got the insert tab where we can insert new pages, visuals, and things like that, create native reports, and integrate Power Apps or Power Automate. The modeling, we've got modeling tab, we've got views where we can select themes. Again, these are fantastic actually because they kind of design them with accessibility in mind. I'm just using the current theme, but later on I tend to go away and it's got sort of like different accessibility considerations that you can just click through and we'll see how that works. We'll read that. So we've got the mobile layout. So yes, this is a very, very good thing to know. So when you create your reports here, with your visualizations, they tend to represent what it would look like on a desktop, right, or a laptop. It's always, in this day and age, organizations are quite global. Pretty much people work everywhere out of the world. So we can create mobile layouts as well. And that means people can still consume the information or the data or the insights and follow the story on the move. Okay, we'll talk about that as you go through. We've got the optimize tab and we've got the help. Help, very, very important. We've got some guided learning here that you can sort of follow just to get different perspectives. Some more training videos and some documentation to follow if you are that inclined. For Power BI for developers, you can connect to GitHub, you can connect to all sorts of develop sort of ancillary services. So coming to the point of importing some data, we'll just go get data. Of course, we've got some common data sources here. You could bring in data from an Excel workbook. Somebody else could create what is called a Power BI semantic model. So again, when we create the model here in the model view, you call it a semantic model, and you can always bring that in here and create some visualization and some reports within the space. It could be data flows to be connected to a dataverse, right? For its SQL endpoint, SQL servers, analysis services. In this case, we're going to be using text from CSV. Indeed, you could also import data from a web URL if the data was hosted somewhere, say on a Kaggle site, for instance. You could pull it in and so forth. So we'll just quickly click on there. And of course, you navigate to the folder where you are holding the data. And we're just going to select the stop calls in this case and pull that in. And what will happen is you'll get this sort of summary window come up. Tells you a little bit about what's going on in the data. You can just have a cursory look at that. Typically, if the data has already gone through some transformation phase within your process, again, depends on how you architect the data pipeline from the source. This is the extract, load, BTL, essentially, extract, transform, load paradigm. Okay, so you extract the data and then you transform it by doing some cleaning, some organizing, some validations and things like that. Make sure that it is fit for purpose, and then you load it into your OLAP, online analytical processing phase of your data pipeline. So typically you go from OLTP to OLAP, online transactional processing, to online analytics processing. Okay. All right. So here in this case, we will just select the choice to transform the data, just to sort of like go through what is going on with the data. Again, when you see here, your window might not look exactly like mine. Okay, that's because I have put on some settings to just give me a visual, some sort of visual feedback about what is going on in the data set. But even that can be misleading sometimes. But how do you turn this on? Okay, you're asking a question. So if you went to your view here, as you can see, the formula bar is there. The column quality is there. So if I take that off, as you can see, the column quality turns off. I can turn that on as well. Show white space. Again, I don't really see the benefit of that there, but I put it on anyway. Column profile, you can turn that on. It kind of gives you a color profile at the bottom there if you're interested in that. And of course, the column distribution has well, and it kind of shows you what is going on in it. So again, that's how you get that view. If you were interested in having exactly the same view as I have, when you come into the Power Query editor, because this is what it is, so when you select to transform the data, it loads up this other tool that is integrated within Power BI called Power Query. And the query edit, again, you can see all of these information that you have here. Right, we'll just obviously go through your data just to make sure that everything is as it should be. For instance, again, you can have a look on here. You can see there that when you look up here, it says there's no error in the data, but when you do look into the drop down, you can see that there are some null values, and of course we don't want null values in our data. I'll talk a little bit about why that can be a problem for us. But again, you just have a look, and on there next to the data, the column name, you can see what type of data it is. And this is text for service ID, train operating companies, text again, value, station codes, text. A planned arrival time is what you call a date time, and you can see the difference there. It's got a calendar for the date and it's got a clock for the time, as opposed to the service date, which is just a date. If it is just a date, you can say calendar there. Okay. Again, delay minutes should be numbers. Makes sense. Right, first time flag should, again, is held as a number, but you will notice that this is asking a logical question, right, which outputs a Boolean result, right? So it could either be it was right, like it came at the right time, was dispatched at the right time, or it wasn't dispatched at the right time. So that's either true or false. And as you can see there, it's represented as ones and zeros. Okay, so that was true and that was false, and so forth. Again, this gives us an opportunity to quickly go in there and just correct the logic and say we want to capture that as a true or a false as opposed to 1 or 0, just so that it is human readable. Okay, so I'm just going to click on that, and as you can see here on the right hand side of this Power Query editor, we have our applied steps. So anything that you do to the data within this window gets captured in this history, and you can always go through that. One thing I like to do is to rename this, because as you go through your data transformation processes, those steps can pile up, and then again, it gives them very, very nondescript, arbitrary names of the actual activity you did, but there's no meaning to it. So for me, I like to just say, okay, right time flag true false. Again, it just gives me something false that makes no sense. Flag, call it flag, and it's true or false. Just hit enter on your keyboard and it accepts that change that you have made. I continue to change this. This just says to 3 flag. Again, this is a ORR benchmark value. Again, how late was the service? Was it 3 minutes within a 3-minute threshold, or was it a 5-minute threshold lateness, or perhaps it was a cancelled service? Again, because this is a Boolean logic that's been represented by that column, I'm just going to make that true or false. I'm going to make also the top 5 flag true or false as well. And again, was this cancelled or was it not cancelled? Okay. And I'm just going to make that true or false as well. So again, this is giving me some sort of understanding already of what's going on in my data set as far as the operations that have been captured. Okay. And we're going to deal with the issue of having null values next. And you probably notice if you went through the data, when you get your data, you can just have a cursory look from the drop down over there and just make sure that you don't have null values. You can have null values for various reasons. In our case here in the planned arrival, everything is there because there's a plan, but of course all plans are perfect until actual first contact. So if we look at the actual arrivals, you'll find that some of them have a null value. indeed does reason that you will also have some null values in the delay minutes, because the delay minutes are basically calculated from the difference between obviously the planned arrival and the actual arrival. Again, we see these null values because clearly some stops are cancelled, okay? Or so these stops perhaps have no actual recorded actual arrival time in the source date. And it means that any cancelled stops have been intentionally stored as a null value, or sometimes it might even be a blank, okay, within the data set that's come from the source. Now, if we then decided to classify delay minutes alone in terms of performance, then of course we will get errors in our performance band. Why would we have errors in there? Because that would lead to misleading averages. So again, if you're looking at any calculations, aggregations, it'll be misleading. Okay. There are some times where you can drop null values, but we'll look at that specifically in a different session. How do we deal with this? Some of the best practice that you find out there suggests that we have to normalize the null values and deriving some sort of safe fields within the data sets that allows us to then say, right, we are confident in what it is that we see in our data. So normalizing the nulls means that you want to make sure that if there are any null values, Power BI's engine will understand what those null values mean. Because, for instance, you might have a null value that is related to a text field. You might have a null value in station code, for instance, and you might have null values in, say, your delay minutes, okay, which is a numeric field. If we don't normalize what these null values mean, then the semantic model will not understand what they mean, and basically that can break your joins, or any joins you want to make between your truth table and your dimensions, which you need to use to slice and contextualize the truth table. And even just basic mathematical aggregations that you might want to do, you will find that you would have problems with that. Okay, so apart from making sure that everything has the proper data types, right, associated with them, with all of the data that you're collecting, you want to figure out a way to handle your null values. So when you bring in raw data, you'll find that raw data columns don't always encode enough meaning. Okay, what the raw data is about. For example, when we have delay minutes, of course, we clearly have some null values associated with null values in actual arrival time. Okay, we can find that we have null values both when a train is cancelled and also when no arrival was recorded of the actual service. These are two distinct business states in terms of the operation of delivering the train service, two different business states. Creating a safe field means that we want to ensure that there is no ambiguity, because that's the trouble with null values. It's not that null values are inherently some sort of bad thing. It's the ambiguity that can come with that. And of course, that can create all kinds of distortions in terms of the understanding of the data and subsequently the insights and on the basis of that. Okay, so there are some strategies that we are going to take to try to deal with this matter. So since we have this context that we've discovered, we're going to try and create a service outcome flag. Okay, so this is what we're going to do. We're going to go to add column, and it's going to be a conditional column. Okay, we can write this in code, but since this is an introductory walkthrough, we're not going to do that. We're just going to use the wizard as here. It's very, very powerful, and you can just build your conditional statements with this. In this case, we're going to say we want a column that is our service outcome. All right. And we want to say that our service outcome is if the cancel flag equals true, because remember we changed these from ones and zeros to true or false. Is a false. Okay, so we're saying that if the cancel flag equals true, then we want to say the output is cancelled. Nice and easy. Can put the condition against another column. In this case, we'll put the condition against the actual arrival. Okay, that is no. Then please tag that as no. Record. Nice and easy. We finish it with else. We say the train actually arrived at the stop. Okay, and once we hit OK, you will find that on the basis of that logic, we have this outcome that helps us to treat the condition of null within our actual arrival column and, of course, delay minutes, okay, related to the cancellations. All right. Now that we've done that, we can also still handle the actual delay minutes associated null values explicitly. Okay, so how are we going to do that? Our purpose here is to treat cancelled or known as null, and then of course guard against errors when we try to pull the data into the analytics aspects of things. So we are going to create a custom column with code. Okay, and we're going to call this delay minutes, and I'll call it delay minutes computed. And basically, the formula here is going to say if service outcome, okay, if service has the okay, then as null. Okay, we don't worry about that. Okay, in this case, let's have that. I want to keep it just as null. Okay, but can value that of. Else we on the basis of on the basis of actual arrival minus arrival. Okay, null as well. Okay, so we deal with these specifically. Okay, I'm just gonna call this null as well. Okay, now once we've done this, it is okay. We have the delay minutes computed. Okay, and you see similarities with our actual delay minutes, but we've computed it dealing with any null values or errors in this case. Okay, now that we've done that, we can obviously start to look at building our performance bands. Okay, we can build it as simple as we like or as extensive as we like. We can do this again with conditions. We can start up a conditional column, and we're going to call this column our performance band services. What does this look like? So we are going to say if service outcome is cancelled, then cancelled. Then we build another else if on the delay minutes computation again, and this time or to 0. Then we want to tag it as on time. That's what we like. And we focus on our delay minutes computation again, else if it is less than or equal to again, less than or equal to this. Okay. Then we are going to say it is a delay. Okay, a minor delay between 0 to 3x. All right, just to put it that way. I like keeping things verbose, as I said earlier. Else if Again, we can just, if the delay minutes that we have computed is less than or equal to 5, again, this is the other compliance measure, 3 to 3 minute flag to 5 minutes. Okay. Again, we'll call this, well, we'll just say this is within 5 minutes. Okay. So we can deal with it. Again, you can build as many of these else ifs as you like, as long as it captures the logic of the operation. And this time we say equal to or less than or equal to 10. Then we're going to call it a moderate delay. Okay, a moderate delay, and this time was 5 to 6. Else it's a significant delay. Okay, else it's a significant delay of 10 plus minutes. Okay, and we've built that, and that becomes our performance band on the basis of the service outcome and the computed delay minutes, which handles the null values and potential for errors. And we say, okay. And as you can see, we've got this performance band in there. Just even looking at it the way it is over here, you can already get the sense of how this might translate to a dashboard, okay, where people are collecting information. What next are we going to do? We can add an hour of the column, because we might want to be able to slice and dice the data in that sense. Again, we would use the custom column creation this time. And very, very easily, we're going to give it a name, our day. As you can see, we're using different methods to create this additional columns in using code. Conditional logic, yet I would just say if you started out, just use the wizard, then makes life easy for you. So the time dot be hour function. Okay, so time dot hour, the second one down. If you tab, it should auto-complete it, but it's made it double this time. So time dot hour on the basis of the planned arrival. Planned arrival. All right. And that's it. We'll just say okay, and voila, hour of day, and have all of these hours of the day. Okay. Once we've done this, and we can also add the specific time periods, again associated with the hour of the day, just to capture even more granularity in the granularity about the operation. And this is how we will do that.